Okay, we will be looking at the third application of dimension analysis. So we have looked at how we use dimension analysis to derive the dimension of quantities, and we have looked at how we use dimension analysis to prove the correctness of an equation, and here now we want to use dimension analysis to derive an unknown formula. Many a times we always have questions in physics that we even don't know the right formula to apply. Dimension analysis can come in to assist in this case. So, and we will use this simple example to explain that. Let's consider the case of a simple pendulum, in which we have the period t of a simple pendulum depends on the length L of the thread and the acceleration due to gravity g. Using dimension analysis, derive the relationship between t, L, and g. So, and let's quickly look at the solution here. Now, this is how a typical simple pendulum bulb looks like. Let's say we have the thread attached to the support and we have this bulb. Of course, if you apply a little force like this, the bulb begins to go to and fro, comes this way, and it comes back like this. Like this, like this, like this. So, and in which this is the length of the thread, and of course the period is time taken for this bulb to move from here back to here for a complete oscillation. So, and this period t depends on the length L of the thread and the acceleration due to gravity g. So, and you remember from our variation that this will become t equals to k, L, and g. And in this case now, we want to know the power to which L is raised to and the power to which g is raised to. We don't know them. So let's assume that the powers are x and y. So, and since k is constant in this case, which means it is a dimensionless constant. So I can just remove it and say my t becomes what? L raised to power x and g raised to power y. So let's now substitute their dimensions individually. Dimension for period, anything that has a unit of time will have a dimension of t. So don't get confused. This t here means the period, but since t is time and the dimension for time is still t, so I will still leave this as t. Dimension for length, anything that has a unit of meter will still have the dimension as L, of course raised to power x, and g is acceleration due to gravity, which is still acceleration. And dimension for acceleration is Lt minus 2 from our first class and raised to power y. Oh yeah, let's open now. So this becomes what? T equals to L raised to power x, L raised to power y, then t raised to power minus 2y. So we can see that I only have t here, but I don't have L. And you remember that if I say a raised to power 0 is equals to 1. So that means I can just decide to bring L raised to power 0 here. Why? Because L raised to power 0 is still 1. So that I will have L on this side and I'm going to have L on this side too. So I can just make this one becoming L raised to power 0, t raised to power 1 equals, so I have L raised to power x, L raised to power y from indices. This becomes L raised to power x plus y. And this t will become t raised to power minus 2y. So I can compare my coefficients now. Compare coefficients. Compare coefficients. So for L, what's on L here? 0 equals to what's on L here? X plus y, equation 1. And on t, what's on t here? 1 equals to what's on t here? Minus 2y, equation 2. So from this equation 2, I can just say, therefore, my y will become what? Minus 1 all over 2. From this equation 2 straight. So let's substitute the value of y into equation 1. So in my equation 1, I have x plus y equals to 0. And what's my y here? Minus half. X plus minus half equals 0. Plus times minus is minus. So that means x minus half is equals to 0. Therefore, my x becomes half. So I now have my x becoming half and my y becoming minus half. So I can now substitute the values of x and y into this place so that I can get the relationship between my t, l, and g. So I have my t becoming k l raised to power x, g raised to power y. So I can now have my t becoming k l raised to power, what's my x? Half. And what's my g? Minus half. So from indices, we also know that a raised to power half is equals to root a. And a raised to power minus half is equals to 1 all over a raised to power half. 1 all over root a. So that means I can say, therefore, my t will become what? K root l, then times 1 all over root g. So which becomes k root l all over g. So this k is a constant, so which can be experimentally obtained. Let's say if our k becomes 2 pi, therefore my t will become what? 2 pi root l all over g. So this shows that the relationship between my period of a simple pendulum L and G can be expressed as T equals K root L over G. And if my K is 2 pi, my T will become T equals to 2 pi root L over G. So you can lay your hands on more questions and you will still get the same thing and just follow the same process. So note that this class is still brought to you by Valdymas College of Advanced and Preliminary Studies. Thank you.